Hello there, and welcome. In this bedtime story, we are going to take a journey through our solar system, starting right at the center with the sun, and then to the rest of the planets. This will be a calm, steady voyage through space, one planet at a time, where we'll take our time to appreciate the beauty, complexity, and wonder of each celestial body. But before we begin, let's take a moment to settle in. Take a deep breath. Let your shoulders relax. You don't need to focus hard. You don't need to memorize facts. You're just here to listen, to enjoy. Let your mind drift into space. You are about to explore the heart of our solar system, the oldest and brightest thing you've ever known, the sun. Let's begin. The sun is a star, a G-type main sequence star, often called a yellow dwarf. Despite the term dwarf, the sun is massive. It makes up 99.86% of the total mass of the entire solar system. Everything, the planets, asteroids, comets, orbits the sun because of its powerful gravitational pull. It's enormous. The sun's diameter is about 1.39 million kilometers, or 109 times wider than Earth. Over 1 million Earths could fit inside it. It weighs about 330,000 times more than our planet. Trying to imagine that scale is mind-boggling, but it helps us appreciate the sun's immense power. The sun formed about 4.6 billion years ago from a cloud of gas and dust. Gravity pulled most of the material into the center, creating the sun, while the rest form the planets and other objects. The sun is currently in the middle of its life and has about 5 billion more years to go before it becomes a red giant and eventually a white dwarf. At its core, the sun is a nuclear fusion reactor under intense pressure and temperatures of around 15 million degrees Celsius. Hydrogen atoms fuse to form helium. This process releases an enormous amount of energy, enough to power the entire solar system. Every second, the sun converts around 600 million tons of hydrogen into helium. That energy travels outward from the core through several layers. First is the radiative zone, where energy slowly moves as radiation. Then comes the convective zone, where hot gases rise and cooler gases sink in a constant churn. Finally, energy reaches the surface, the photosphere, which is what we see from Earth. The photosphere is about 5,500 degrees Celsius. Above the photosphere are the chromosphere and the corona. The corona is the sun's outer atmosphere, and it's surprisingly much hotter than the surface, over 1,000,000 degrees Celsius. The reason for this extreme temperature is still a mystery to scientists. The corona is visible during a total solar eclipse, appearing as a glowing halo around the sun. The sun's surface is dynamic. Sunspots are cooler, darker areas caused by intense magnetic activity. Solar flares are sudden explosions of energy, while coronal mass ejections, CMEs, send huge clouds of solar particles into space. These events can affect Earth, disrupting satellites and power systems, but they also create beautiful auroras near the poles. The sun constantly emits solar wind, a stream of charged particles that flows through the solar system. This wind forms the heliosphere, a vast bubble that protects us from much of the radiation in interstellar space. The heliosphere marks the boundary of the sun's influence. The sun is vital for life on Earth. It gives us light and warmth, drives our weather and climate, and enables photosynthesis, which plants use to produce oxygen and food. The changing angle of sunlight through the year gives us seasons. Our days and nights are measured by the sun's apparent movement in the sky as Earth rotates. Culturally, the sun has been revered in many ancient civilizations. Egyptians worshipped the sun god Ra. In Hinduism, Surya is a powerful sun deity. The Aztecs believed their sun god needed regular offerings to keep shining. These stories show just how central the sun has always been to human life. In modern times, we've studied the sun with satellites and probes. Missions like SOHO, SDO, and Parker Solar Probe have taught us more about the sun's magnetic field, solar storms, and how energy moves through its layers. Understanding the sun helps us protect our technology and deepens our knowledge of other stars. The sun shines across the entire electromagnetic spectrum, from radio waves to gamma rays. Most of its energy is in the visible range, which we see as sunlight. Our atmosphere filters out most harmful ultraviolet radiation, but enough UV light reaches us to help our bodies produce vitamin D, though too much can cause sunburns and skin damage. Eclipses give scientists a rare chance to study the sun. During a total eclipse, the moon blocks the sun's bright surface, revealing the corona. These moments have led to important discoveries, such as confirming predictions made by Einstein's theory of general relativity. The sun also defines time. A day is the time it takes Earth to rotate once, marked by the sun's movement in the sky. Our sense of time, days, seasons, years, all revolves around the sun. In conclusion, the sun is more than a glowing ball of light. It's a powerful, dynamic star. It fuels life, shapes weather, powers technology, and connects every part of our solar system. As we leave the sun and head toward Mercury, we carry with us a deeper understanding of the force that holds everything together. As we drift away from the glowing majesty of the sun, we find ourselves approaching the first planet in our solar system, Mercury. It is the smallest of all the planets and the closest to the sun. From here, the sun looks more than 3 times larger than it does from Earth, and the sunlight is more than 7 times as intense. Mercury is a world of extremes, a place where temperature, light, and shadow create a truly alien landscape. Mercury is named after the Roman messenger god, known for his speed, and fittingly, it is the fastest moving planet in our solar system. It orbits the sun at an average distance of about 58 million kilometers, 36 million miles, and completes a full revolution in just 88 Earth days. That means a year on Mercury lasts less than 3 months on Earth. But interestingly, Mercury's day is longer than its year. One full rotation on its axis, a Mercurian day, takes about 59 Earth days. Because Mercury lacks a significant atmosphere to trap heat, its surface experiences some of the most extreme temperature swings in the solar system. During the day, temperatures can soar up to 430 degrees, 800 degrees, hot enough to melt lead. But at night, without the warmth of an atmosphere, the temperature plummets to 180 degrees and 200. This dramatic contrast makes Mercury both a furnace and a freezer, depending on where and when you are. Its surface is rugged and ancient, heavily marked with impact craters, ridges, and plains. It looks somewhat similar to our moon. One of the most prominent features is the Calorus Basin, a massive crater so large it could fit the entire state of Texas. This impact site likely formed billions of years ago from a massive collision with an asteroid, sending shock waves across the entire planet. Mercury is a dense world. In fact, after Earth, it is the second most dense planet in the solar system. This high density is due to its large metallic core, which makes up about 85% of the planet's radius. The core is primarily composed of iron and nickel, and is surrounded by a silicate mantle and a thin, rocky crust. Scientists believe that Mercury's massive core may hint at a dramatic past, perhaps the result of a violent collision early in its history that stripped away much of its original outer layers. Despite its small size, Mercury has a magnetic field, although it's only about 1% as strong as Earth's. This was a surprise to scientists when it was first detected by NASA's Mariner 10 spacecraft in the 1970s. A magnetic field suggests that Mercury's core is at least partially molten. The presence of a magnetic field also leads to interesting interactions with solar wind, resulting in brief but intense magnetic storms around the planet. Mercury's surface holds clues about its complex geological past. Spacecraft images show signs of volcanic activity, such as ancient lava plains and long cliffs called lobate scarps, formed as the planet cooled and contracted over time. These scarps can stretch for hundreds of kilometers and rise up to a kilometer high, testifying to the planet's active and shrinking interior. Unlike Earth or Mars, Mercury doesn't have any moons, and with its thin, almost non-existent atmosphere, called an exosphere, there is little weather to speak of. This exosphere is made of atoms blasted off the surface by solar radiation and micrometeorite impacts. These atoms, mainly hydrogen, helium, oxygen, sodium, calcium, and potassium, are so sparse that they barely form anything like the air we know. One of the most fascinating things about Mercury is the presence of water ice in permanently shadowed craters near its poles. Despite its proximity to the sun, these deep, dark regions never receive sunlight and remain cold enough below 170 degrees to trap and preserve ice. Radar observations from Earth and close-up views from NASA's Messenger spacecraft confirmed the existence of this ice, suggesting that even on this blistering world, frozen water can survive under the right conditions. Mercury has been visited by only 2 spacecraft so far. The first was Mariner 10, which flew by 3 times between 1974 and 1975 and gave us our first close-up views. The second was Messenger, which orbited Mercury from 2011 to 2015 and revolutionized our understanding of the planet. Messenger mapped the entire surface, analyzed the chemical composition, measured the magnetic field, and discovered those polar ice deposits. Thanks to Messenger, we learned that Mercury is far more dynamic and complex than previously thought. Now, the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA, are working together on a mission called Bepi Colombo, launched in 2018. It's on a 7-year journey and is expected to arrive at Mercury in 2025. Once there, it will separate into 2 orbiters to study the planet from different perspectives, continuing to unravel the mysteries of this small but significant world. Although Mercury is often overlooked in favor of more colorful or Earth-like planets, it is a fascinating place in its own right. Its harsh environment, ancient landscape, and geological surprises make it a key to understanding the early history of the solar system. As we leave Mercury behind, we prepare to journey onward to our next destination, Venus, the second planet from the Sun and Earth's mysterious twin. Unlike Mercury's airless surface, Venus is cloaked in thick clouds of sulfuric acid, hiding a world of crushing pressure and volcanic plains. Venus is the second planet from the Sun. From a distance, Venus shines brilliantly in the sky, often referred to as the morning star or the evening star, depending on when it's visible. It's one of the brightest natural objects in Earth's night sky, outshined only by the moon. But despite its beauty, Venus is a world of extremes, hot, hostile, and wrapped in a thick veil of cloud that has kept its secrets hidden for centuries. Venus is often called Earth's twin, not because of its environment, but due to its similar size and structure. It's just a bit smaller than Earth, roughly 95% the size of Earth, and it has a similar mass and density. Scientists once thought Venus might even host oceans or jungles beneath its clouds. But we now know that the surface of Venus is one of the most extreme and unforgiving places in the solar system. The atmosphere of Venus is incredibly dense and composed mostly of carbon dioxide with clouds of sulfuric acid. This thick atmosphere traps heat in a runaway greenhouse effect, making Venus the hottest planet in our solar system, even hotter than Mercury, which is closer to the Sun. It's so hot that spacecraft that land on Venus only survive a few minutes to a couple of hours before they stop functioning. Pressure is another challenge. The atmospheric pressure at Venus's surface is about 92 times greater than Earth's, equivalent to the pressure you'd feel 900 meters, 3,000 feet underwater. Combine that with toxic clouds and scorching temperatures, and it's clear why Venus is one of the most inhospitable places we've ever studied. Despite this, Venus is a fascinating planet, rich in geological and atmospheric phenomena. The surface is relatively young, geologically speaking, with wide lava plains, volcanic mountains, and strange features known as coronae, large circular structures that may have formed from volcanic activity. There's evidence of volcanoes that may still be active today, suggesting that Venus might not be as geologically quiet as once believed. One of the most mysterious things about Venus is its rotation. Venus rotates backwards or in retrograde, meaning the sun would appear to rise in the west and set in the east, the opposite of what we see on Earth. Even more surprising is how slowly it spins. One day on Venus, from one sunrise to the next, lasts about 203 Earth days. Strangely, its year is shorter than its day. Venus takes about 225 Earth days to orbit the Sun, so a day on Venus lasts longer than a year. Because of its thick atmosphere, very little sunlight reaches the surface, and what does is scattered and filtered through thick clouds. The skies are likely a yellowish orange with no clear view of the sun or stars. Lightning has been detected in the Venusian atmosphere, suggesting intense storms, though no rain ever reaches the ground. It evaporates long before hitting the surface. The surface of Venus has been mapped in detail thanks to radar imaging, particularly from NASA's Magellan spacecraft, which orbited Venus from 1990 to 1994. Magellan used radar to see through the clouds and reveal a vast landscape of mountain ranges, volcanic plains, rift valleys, and impact craters. One of the tallest mountains is Maxwell Montes, which rises about 11 kilometers, 7 miles, taller than Mount Everest. Venus has no moons and no magnetic field, possibly due to its extremely slow rotation. Its lack of a magnetic shield leaves the atmosphere vulnerable to the solar wind, which slowly strips particles away into space. Over billions of years, Venus may have lost vast amounts of water in this way. In fact, some scientists believe that Venus may have once had oceans, perhaps even been Earth-like, before a runaway greenhouse effect transformed it into the harsh world we see today. Our exploration of Venus began in the early days of space travel. The Soviet Union was the first to reach Venus with its Venera missions. Venera 7 in 1970 was the first spacecraft to successfully land on another planet and transmit data back. Later missions, like Venera 9, even sent back the first images from the surface, showing rocky, desolate terrain under a heavy yellow sky. These missions were short-lived due to the planet's harsh conditions, but they provided valuable information. Since then, other missions have followed, including NASA's Pioneer Venus, ESA's Venus Express, and Japan's Akatsuki, which is currently in orbit around Venus, studying its weather and atmosphere. These missions have revealed that Venus has super-rotating winds, much faster than the planet itself rotates. In recent years, there has been renewed interest in returning to Venus. NASA's upcoming Veritas and Da Vinci Plus missions, along with ESA's Envision, are set to launch in the coming decade. These missions aim to explore the surface, atmosphere, and history of Venus in more detail, and maybe even answer one of the most tantalizing questions. Could Venus once have supported life? In 2020, scientists detected a molecule called phosphine in Venus's upper atmosphere, a possible sign of microbial life. Though still highly debated, phosphine is often associated with biological processes on Earth, and while it could be created by unknown chemistry on Venus, the discovery has reignited questions about the planet's potential past and even present habitability. Venus is a planet of contrasts. It's Earth's twin in size and structure, but could not be more different in environment. Its dense, toxic skies and blistering surface temperatures tell the story of a planet that may have started out much like Earth, only to become something completely alien as we leave the sweltering beauty of Venus behind. We set our sights on a planet that, in many ways, feels like coming home. Up ahead lies the blue world of Earth, our oasis in the cosmos, the only place we know so far that harbors life. But from the vantage point of space, even Earth looks like a fragile sphere suspended in the darkness. A delicate sphere of blue, white, green, and tan, Earth floats like a jewel wrapped in thin, swirling clouds. It is our home, the only place we know of so far that supports life in all its complexity. From space, Earth is breathtaking. About 12,742 kilometers, or 7,918 miles in diameter. It's slightly larger than Venus and about 4 times wider than the Moon. What sets it apart, though, is its diverse surface, its atmosphere, and most of all, its life. More than 70% of Earth's surface is covered by oceans, which give it its brilliant blue hue when viewed from above. The rest is made up of continents, mountains, deserts, forests, and icy poles, a variety of landscapes shaped over billions of years by water, wind, plate tectonics, and time. Earth formed about 4.4 billion years ago, around the same time as the Sun and the rest of the solar system. Over time, its surface cooled, water collected in basins to form oceans, and life began, starting with microscopic organisms more than 3.5 billion years ago. Since then, Earth has become a rich, vibrant world, teeming with plants, animals, fungi, bacteria, and more. One of Earth's most unique features is its atmosphere, a mixture of 78% nitrogen, 21% oxygen, and trace amounts of other gases like carbon dioxide and argon. This atmosphere protects us from harmful solar radiation, helps regulate the planet's temperature, and allows weather systems to form. It also contains the ozone layer, which shields living things from the sun's ultraviolet rays. Earth's magnetic field, generated by its liquid iron outer core, also plays a vital role in protecting life. It deflects much of the solar wind and cosmic radiation that could otherwise strip away the atmosphere and damage living organisms. Without it, Earth might look more like Mars. Unlike the other planets we've visited so far, Earth is in what's known as the habitable zone, the perfect distance from the sun for liquid water to exist on its surface. This is one of the key ingredients for life as we know it. The average surface temperature on Earth is about 15 degrees, 59 degrees, but that varies greatly depending on location and time of year, from scorching deserts to icy tundras. Earth's tilted axis, about 23.5 degrees, gives us our seasons. As the planet orbits the sun over the course of a year, different parts of Earth receive varying amounts of sunlight. This tilt is responsible for the changing length of days, the cycles of plant life, and the natural rhythms many animals follow. The planet also rotates on its axis once every 24 hours, giving us day and night. This rotation helps drive wind patterns, ocean currents, and the general balance of heat across the planet. Meanwhile, Earth's orbit around the sun takes about 365.25 days, which is why we have leap years every 4 years to keep our calendars in sync. Earth is also the only planet with tectonic plates, massive sections of the crust that slowly move over the mantle beneath. Their movements cause earthquakes, build mountains, and form volcanoes. Over millions of years, they have reshaped continents and influenced the development of ecosystems. This constant geological activity helps cycle important elements like carbon and water through the planet's systems. Our planet has one moon, simply called the Moon. It's the 5th largest moon in the solar system and is thought to have formed after a Mars-sized object collided with Earth billions of years ago. The moon's gravity stabilizes Earth's tilt, affecting our climate, and causes ocean tides by pulling on Earth's water. Its presence has played a big role in Earth's development, both geologically and biologically. Earth's biosphere, the sum of all living things, exists in a delicate balance. Life depends on the cycling of water, carbon, nitrogen, and other elements. Plants absorb carbon dioxide and release oxygen. Animals do the opposite. Microbes break down waste and recycle nutrients. Every piece of the puzzle fits together in a system that has evolved over billions of years. Human beings are just one species among millions, but our influence on the planet is vast. In just a few thousand years, we've built cities, crossed oceans, developed agriculture, and traveled into space. Our ability to learn and adapt has allowed us to thrive in every environment, from rainforests to deserts, from deep oceans to high mountains. But with this growth comes responsibility. Human activity is altering Earth's atmosphere, oceans, and ecosystems. Climate change, deforestation, pollution, and loss of biodiversity are serious issues that threaten the planet's stability. Still, Earth is resilient, and with care and science, many of these problems can be addressed. Earth has been explored more than any other planet, of course, but there's still so much we don't know, from the deep sea trenches to the edges of our atmosphere, and from the microbial world to the vast systems that regulate climate. Scientists study Earth from space too. Satellites orbit the planet to monitor weather, measure sea level rise, track storms, and study environmental changes. From the International Space Station, astronauts often describe a feeling called the overview effect, a deep emotional response to seeing Earth from above. They see no borders, just one fragile world, shimmering in the vast darkness of space. It's a reminder of how rare and precious our planet really is. As we prepare to move beyond Earth in our journey, it's worth reflecting on what makes it special. It's not just the temperature, the atmosphere, or the water. It's the life. So far, Earth is the only known place in the universe where life exists. Every tree, fish, insect, bird, and person is part of an intricate, dynamic web of existence that continues to evolve. We may search the stars for other habitable worlds, but for now, Earth remains our only home. It's a place of wonder, beauty, and complexity, and it reminds us of both how far we've come and how much there still is to discover. As we leave Earth behind, just for a moment, we turn our gaze to a planet glowing red in the distance. It's a world that has fascinated humanity for centuries, filled with mystery and a promise of discovery. Our journey now takes us to Mars, the red planet. Hanging in the darkness like a dim orange ember, Mars has long been a subject of fascination. Ancient astronomers noticed its unusual color and erratic motion across the sky, and today it continues to capture the imagination as a place of both mystery and possibility. Mars is often called the red planet because of its distinct hue caused by iron oxide or rust covering its surface. When sunlight reflects off the dust and rock, it gives the planet a reddish glow that can be seen even from Earth with the naked eye. Located about 228 million kilometers, 142 million miles from the Sun, Mars is the fourth planet in the solar system. It's about half the size of Earth and has only about 38% of Earth's gravity. If you weigh 100 pounds on Earth, you'd weigh just 38 pounds on Mars. Mars has two small moons, Phobos and Deimos, likely captured asteroids. They're irregular in shape and much smaller than Earth's moon. Phobos, the larger of the two, orbits Mars so quickly that it rises in the west and sets in the east, all in the span of just 11 hours. Despite its dry, dusty appearance today, Mars shows strong evidence that it once had liquid water flowing across its surface. Ancient river valleys, lake beds, and mineral deposits suggest a time when Mars had a much warmer, wetter climate. Some scientists believe that Mars may have even supported simple microbial life billions of years ago. Whether life ever emerged or still exists in hidden underground environments remains one of the greatest scientific questions. Mars' atmosphere is extremely thin, just about 1% the density of Earth's, and is composed mostly of carbon dioxide with traces of nitrogen and argon. Because of this, it can't support human life directly, and surface temperatures fluctuate wildly. Despite the harsh environment, Mars has weather. The planet experiences dust storms, some of which are massive enough to cover the entire globe for weeks. These storms, while not particularly dangerous due to the thin atmosphere, are strong enough to reshape the landscape and block sunlight from solar-powered rovers. One of the most striking features on Mars is Olympus Mons, the tallest volcano in the solar system. It stands at a staggering 22 kilometers, 13.6 miles high, nearly 3 times the height of Mount Everest. Its base is about as wide as the entire state of Arizona. Because of Mars' lower gravity and lack of plate tectonics, Olympus Mons was able to grow so large over millions of years without being disrupted. Another awe-inspiring landmark is Valles Marineris, a system of canyons stretching over 4,000 kilometers long and up to 7 kilometers, 4.3 miles deep. It's one of the largest canyon systems in the solar system, dwarfing Earth's Grand Canyon in every way. Its origins are still debated, but many scientists believe it formed as the planet's crust stretched and cracked, perhaps influenced by volcanic activity nearby. Mars also has polar ice caps made mostly of frozen carbon dioxide, dry ice, and water ice. These caps grow and shrink with the changing seasons, and in the warmer months, you can even see spiral-shaped patterns in the layers of ice, a record of Martian climate changes over time. Seasons on Mars are similar to those on Earth, but they last almost twice as long due to its longer orbit around the Sun, 687 Earth days, or about 1.88 Earth years. The planet's axial tilt of 25.2 degrees is also similar to Earth's, which causes these seasonal shifts. For decades, humanity has been sending robotic explorers to study Mars up close. The first successful flyby was made by NASA's Mariner 4 in 1965. Since then, a fleet of orbiters, landers, and rovers have surveyed the Martian surface and skies. The Viking missions of the 1970s were the first to land and transmit images. More recently, rovers like Spirit, Opportunity, Curiosity, and perseverance have explored its rocks, climate, and even drilled into its surface. Perseverance, which landed in 2021, is exploring Jezero Crater, an area believed to have once been a lake. It's collecting rock sample that might contain signs of ancient microbial life, samples that scientists hope to return to Earth in future missions. Alongside it is Ingenuity, a small helicopter that made the first powered flight on another planet, a milestone in interplanetary exploration. Mars has also become a focal point for discussions about human exploration and colonization. Space agencies like NASA and private companies like SpaceX are working on technologies to send humans to Mars in the coming decades. These missions would face enormous challenges: long travel times, exposure to radiation, the need for life support, and more. But they represent a bold next step in our journey beyond Earth. One concept that has gained attention is terraforming, the idea of transforming Mars into a more Earth-like environment. While still in the realm of science fiction, it sparks fascinating questions about humanity's future in the universe. Could Mars one day become a second home for people? Could we grow plants, build cities, and live beneath the red skies? As we drift higher above the Martian surface, the full view of the red planet comes into focus. Its canyons, mountains, and dry plains stretching far beyond the horizon. It is a place of both history and potential, a frozen time capsule of the early solar system and a stepping stone toward the stars. Leaving Mars behind, we continue outward on our journey, heading for a world more distant and mysterious, a gas giant with beautiful rings and powerful storms. Next, we will visit Jupiter, the largest planet in our solar system. Jupiter is the fifth planet from the Sun and the largest of them all. It dominates its region of space, a gas giant so massive that all the other planets could fit inside it with room to spare. Jupiter is often referred to as a failed star, and it's easy to see why. Its composition, mostly hydrogen and helium, is similar to the Sun's, but Jupiter never gained enough mass to ignite nuclear fusion at its core. Still, it radiates more heat than it receives from the Sun, thanks to the leftover energy from its formation over 4.5 billion years ago. Its sheer size is staggering, more than 11 times wider than Earth, and its mass is over 300 times that of our home planet. If you stood on the edge of its swirling cloud tops, Though there's no solid surface to stand on, you'd be looking out across a truly alien world of storms, pressure, and immense gravity. One of Jupiter's most famous features is the Great Red Spot, a massive, swirling storm system that's been raging for at least 400 years, possibly much longer. It's twice the size of Earth, and its winds reach speeds of over 400 kilometers per hour, 250 miles per hour. The storm appears reddish due to the complex chemicals in Jupiter's atmosphere reacting with sunlight high above the clouds. Jupiter's atmosphere is a constantly shifting blend of colors: oranges, whites, browns, and reds, created by clouds made of ammonia crystals, water vapor, and other elements. These clouds form distinct bands that stretch horizontally across the planet, with powerful jet streams separating them. Beneath the outer atmosphere lies a sea of mystery. Jupiter has no solid surface. Instead, as you descend, the pressure increases dramatically. Hydrogen gas is compressed into a liquid, and eventually, near the core, it turns into metallic hydrogen, a strange and exotic form of matter that can conduct electricity and generate Jupiter's powerful magnetic field, the strongest of any planet. This magnetic field creates enormous radiation belts that surround the planet, dangerous enough to fry electronics and pose risks to spacecraft. It's also responsible for some of the most stunning auroras in the solar system, glowing ribbons of light near the poles, much like Earth's northern and southern lights, but far more intense. Jupiter doesn't travel alone. It's accompanied by an impressive entourage of moons, 95 known moons as of today, and possibly more waiting to be discovered. The four largest, Io, Europa, Ganymede, and Callisto, are called the Galilean moons, named after Galileo Galilei, who observed them in 1610 with a telescope. Each of these moons is a world in its own right. Io is the most volcanically active body in the solar system, with hundreds of erupting volcanoes spewing sulfur across its surface. Europa is covered in ice, but beneath that frozen shell may lie a vast subsurface ocean of liquid water, one of the most promising places to search for alien life. Ganymede is the largest moon in the solar system, even bigger than Mercury, and has its own magnetic field. Callisto, with its heavily cratered surface, is thought to be one of the oldest landscapes in the solar system. These moons, especially Europa, are high on the list for future exploration. Missions like NASA's Europa Clipper aim to investigate its icy shell and search for signs of habitability beneath the surface. Jupiter also plays an important role in the broader architecture of the solar system. Its immense gravity acts as a kind of cosmic guardian, sweeping up comets and asteroids that might otherwise pose a threat to the inner planets. Some scientists believe Jupiter's presence helped stabilize Earth's orbit, allowing life to flourish. Over the years, many spacecraft have visited Jupiter to help us understand this gas giant. Pioneer 10, Voyager 1 and 2, and Galileo all sent back stunning data and images. More recently, Juno, which arrived in 2016, has been orbiting the planet in a series of close passes, revealing new insights into Jupiter's structure, atmosphere, and magnetic environment. Juno's images show Jupiter not as a static giant, but as a dynamic, living planet. Its poles are dotted with massive cyclones arranged in geometric patterns. Its deep interior may contain a fuzzy, partially dissolved core, not solid like Earth's, but complex and turbulent. There is still so much we don't know about Jupiter. Its massive storms, magnetic environment, and strange internal chemistry challenge our understanding of planetary science. But every pass of a spacecraft, every new image or measurement brings us closer to unlocking the secrets of this giant. As we drift away from Jupiter's swirling clouds and orbiting moons, we're reminded of how much diversity exists in our solar system. No two planets are the same, and each world holds stories shaped by time, gravity, chemistry, and cosmic chance. From here, our path leads us even farther from the sun, toward a beautiful, ringed planet that has captivated humans for centuries. Our next stop is Saturn, the jewel of the solar system. As we leave behind the massive presence of Jupiter, we journey farther into the cold reaches of the outer solar system. Here, in the dim glow of the distant sun, another giant awaits, Saturn. If Jupiter is the king of planets, Saturn is its elegant counterpart, a planet wrapped in rings so bright and beautiful that they've enchanted observers for centuries. Saturn is the sixth planet from the Sun and the second largest in the solar system. It's more than 9 times wider than Earth. Like Jupiter, Saturn is a gas giant composed mostly of hydrogen and helium, with no solid surface beneath its swirling clouds. What sets Saturn apart are its rings, a feature that makes it one of the most iconic objects in the night sky. While other gas giants also have rings, none are as grand or complex as Saturn's. The rings are made up of countless particles of ice, rock, and dust. Some are no bigger than grains of sand. Others are as large as mountains. These rings are divided into several parts, labeled alphabetically in the order they were discovered. The A, B, and C rings are the most prominent. The Cassini division, a dark gap between the A and B rings, is visible through even a small telescope from Earth. Though they appear solid from afar, Saturn's rings are actually incredibly delicate and complex. Scientists believe they might be relatively young, possibly only a few 100 million years old, and could eventually disappear as particles spiral into the planet or drift off into space. Saturn spins rapidly, completing one rotation in just 10.7 hours, making its days some of the shortest in the solar system. This rapid rotation, combined with its gaseous composition, causes the planet to bulge at the equator and flatten at the poles. Its golden hue comes from ammonia crystals in the upper atmosphere, which reflect sunlight and give Saturn its soft, buttery appearance. Beneath those clouds, Saturn's interior gets hotter and denser, with hydrogen compressed into a metallic form around a likely core of rock and ice. Like Jupiter, Saturn radiates more energy than it receives from the Sun, a sign that it's still slowly contracting from its formation more than 4.5 billion years ago. Saturn's magnetic field is strong, though not as powerful as Jupiter's. It helps trap particles from the solar wind and creates dazzling auroras near the poles, visible in ultraviolet light. These lights dance around Saturn's poles, painting ghostly rings of energy in the planet's upper atmosphere. But Saturn is not alone in its orbit. It is surrounded by a vast and fascinating collection of moons, 146 known moons and counting. Each one has a story to tell. Some are small and irregularly shaped, while others are large enough to be planets in their own right. The largest of them all is Titan, a world shrouded in an orange haze. Titan is the second largest moon in the solar system, even larger than Mercury, and it has a thick atmosphere made mostly of nitrogen. It's the only moon known to have lakes and rivers, not of water, but of liquid methane and ethane. Beneath its frozen surface, scientists believe an ocean of liquid water might exist. Another potential habitat in the search for life. Another remarkable moon is Enceladus. Though only about 500 kilometers, 310 miles wide, it has become one of the most intriguing objects in the solar system. In 2005, NASA's Cassini spacecraft discovered that Enceladus has geysers erupting from its south pole, plumes of water vapor and ice shooting into space from beneath the surface. This suggests a subsurface ocean kept warm by gravitational forces. The idea that life could exist in these deep, dark waters has fascinated scientists ever since. Speaking of Cassini, the Cassini-Huygens mission, which orbited Saturn from 2004 to 2017, transformed our understanding of the ringed planet. Cassini spent over 13 years studying Saturn, flying past its moons, diving through its rings, and capturing some of the most stunning images ever taken in space. In 2017, at the end of its mission, Cassini took a final plunge into Saturn's atmosphere, sending back data until its signal faded forever. Through Cassini, we learn that Saturn's rings are more dynamic and temporary than once thought. We saw storms forming in the atmosphere, including a massive hexagon-shaped storm at the North Pole, a bizarre and beautiful weather system unlike anything else in the solar system. We watch the changing seasons of Saturn, which take over 7 Earth years each, as the planet made its way around the Sun once every 29.5 Earth years. Saturn has long inspired wonder to early astronomers using rudimentary telescopes. The rings were a mystery, sometimes appearing as ears or handles. Galileo couldn't quite make sense of them in 1610. It wasn't until the Dutch astronomer Christian Huygens correctly described them in 1655 that their nature began to be understood. Today, Saturn continues to fascinate both scientists and the public. Its elegance and complexity remind us how diverse and beautiful the planets can be. With its glowing rings, mysterious moons, and swirling atmosphere, Saturn feels almost like a dream, a place from mythology brought to life. As we leave Saturn behind, we head farther into the dark, icy reaches of the solar system. Out beyond lies a pale blue planet known for its sideways spin and icy winds. Our next destination is Uranus, a world of mystery and quiet strangeness. Uranus is the 7th planet from the Sun. Mysterious and quiet, Uranus doesn't call attention to itself with dazzling rings or massive storms. but its uniqueness lies in something very unusual. It spins on its side. Uranus is often called an ice giant like Neptune. While it is still composed mostly of hydrogen and helium, it contains more ices such as water, ammonia, and methane, making its internal structure different from the gas giants like Jupiter and Saturn. It is the third largest planet in the solar system, which makes it more than 4 times wider than Earth. But its most distinctive feature is its axial tilt. Most planets spin with a slight tilt. Earth tilts at about 23 degrees, but Uranus is tipped over at an incredible 98 degrees. It essentially rolls around the sun on its side. This means that for nearly a quarter of its 84-year-long orbit, each pole gets 42 years of continuous sunlight, followed by 42 years of darkness. It's one of the strangest rotations in the solar system. Scientists believe this tilt may have been caused by a massive collision early in Uranus's history, possibly with an Earth-sized object that knocked the planet over. Whatever the cause, this extreme tilt leads to unusual seasons, and it affects everything from its magnetic field to its weather patterns. Uranus has a pale blue-green color, which comes from methane gas in its upper atmosphere. Methane absorbs red light and reflects blue and green, giving the planet its distinctive tint. Unlike Jupiter or Saturn, Uranus doesn't have many visible cloud bands or large storms. Its atmosphere appears calm and featureless in most images. However, enhanced observations have revealed fast winds, thin cloud layers, and seasonal storms hidden beneath the haze. One surprising thing about Uranus is its coldness. Even though Neptune is farther from the Sun, Uranus is actually the coldest planet in the solar system. Scientists aren't sure why Uranus is so cold, but it may be related to its odd tilt, its internal structure, or a lack of heat from its core. Unlike the gas giants, Uranus doesn't radiate much heat, making it unique among the large planets. Uranus also has a magnetic field, but it's just as strange as the planet's tilt. The magnetic field is off-center and tilted at about 60 degrees from its axis. It doesn't line up with the planet's core like Earth's does. This creates a wobbling, lopsided, magnetic environment that shifts in unexpected ways. Surrounding Uranus is a system of faint rings. These rings are much darker and thinner than Saturn's and are difficult to see without specialized instruments. There are 13 known rings made mostly of dark particles. The rings were discovered in 1977 when astronomers noticed starlight dimming as Uranus passed in front of it, evidence of ring material blocking the light. Uranus is also home to a collection of moons, each with its own story. So far, 27 moons have been discovered, many named after characters from the works of William Shakespeare and Alexander Pope. The largest ones, Titania, Oberon, Umbriel, Ariel, and Miranda, are icy worlds with varied surfaces. Some have deep canyons, while others show signs of geological activity in the distant past. One of the most fascinating moons is Miranda, a small and heavily cratered world. Despite its size, it shows signs of massive cliffs and grooves, suggesting it may have been broken apart and reassembled by past collisions. It's sometimes called the Frankenstein moon for its odd, stitched together appearance. So far, only one spacecraft has visited Uranus, Voyager 2, which flew by the planet in 1986. In just a few hours, Voyager 2 collected all the direct data we have about Uranus. It revealed the ring system, discovered 10 new moons, and gave us the first close-up look at this icy, tilted world. Since then, no spacecraft has returned, though scientists continue to study Uranus using telescopes from Earth and space. Despite the lack of recent exploration, Uranus has become a focus of growing interest. Many scientists believe it holds clues to the early history of the solar system, especially regarding how planets form and migrate. Its unique rotation, cold temperatures, and complex interior could help us understand more about exoplanets, worlds beyond our solar system that may resemble Uranus more than Earth. Uranus teaches us that not every planet follows a typical pattern. It reminds us that the solar system is full of surprises, places that defy expectations and challenge our understanding. Its sideways spin, quiet beauty, and icy composition make it a world worth returning to and learning from. Now, as we prepare to continue our journey, we head even farther into the darkness toward the last of the official planets in our solar system. Next lies a deep blue world full of violent storms, powerful winds, and strange moons. That world is Neptune, and it awaits us next. The farthest known major planet is Neptune. It lies nearly 4.5 billion kilometers, 2.8 billion miles, from the Sun, a place where sunlight is weak and distant, and the cold of space wraps everything in silence. Neptune is the 8th planet from the Sun and the 4th largest by diameter. It's just slightly smaller than Uranus, but its mass is greater. That extra mass gives Neptune stronger gravity, making it more compact and dense than its sibling. Like Uranus, Neptune is an ice giant. Its interior is made of icy materials such as water, methane, and ammonia surrounding a rocky core. Above that lies a thick atmosphere of hydrogen, helium, and methane. It's this methane that gives Neptune its vivid, deep blue color, a richer hue than Uranus, even though both contain methane gas. Scientists believe there may be other unknown elements contributing to Neptune's striking appearance. Despite its serene look from a distance, Neptune is a planet of extreme weather. It holds the title for the fastest winds in the solar system, reaching speeds of over 2,000 kilometers per hour. These winds tear through the upper atmosphere faster than the speed of sound on Earth. The planet is home to dynamic storm systems, much like Jupiter. One of the most famous was the Great Dark Spot, a massive storm about the size of Earth. It was first seen by Voyager 2 in 1989. Although it later disappeared, new dark spots have since formed and faded, showing that Neptune's atmosphere is constantly changing. Neptune takes about 165 Earth years to complete one orbit around the Sun. That means since its discovery in 1846, it only recently completed its first full orbit in 2011. Despite being so far away, Neptune rotates quickly, spinning once every 16 hours. This fast rotation helps drive its powerful weather systems. The planet's magnetic field is unusual. Just like Uranus's, it's tilted significantly from the planet's axis and is offset from the center. This creates a warped, twisted, magnetic field that changes as Neptune rotates. Surrounding Neptune is a delicate system of faint rings. There are at least 5 main rings made of dark particles, likely rich in organic compounds. These rings are not as bright or broad as Saturn's, but they do form interesting arcs and clumps, giving them a mysterious character. Neptune also has a fascinating family of moons, 14 in total, as we know today. The largest and most famous is Triton, an icy world larger than the dwarf planet Pluto. Triton is unique because it orbits Neptune backward in a direction opposite to the planet's rotation. This retrograde orbit suggests that Triton didn't form alongside Neptune, but was captured by the planet's gravity long ago. Triton is one of the coldest known objects in the solar system, but it's far from lifeless. It has active geysers that shoot icy material into space. Its surface is marked with frozen plains, ridges, and basins, evidence of past geological activity. Some scientists believe Triton might even have a subsurface ocean beneath its icy crust. Neptune was the first planet discovered through mathematics rather than direct observation. In the 1840s, astronomers noticed that Uranus's orbit wasn't behaving as expected. Based on those irregularities, scientists predicted that another planet must be exerting a gravitational pull. Their calculations led to the discovery of Neptune, proving the power of science and observation working together. To date, only one spacecraft has visited Neptune, Voyager 2, which flew past in August 1989. In just a brief encounter, it gave humanity its first close-up look at the planet. It revealed Neptune's active atmosphere, its rings, and its complex moons. No other missions have returned, but scientists continue to dream of sending an orbiter to explore Neptune and Triton in greater detail. Though far from the warmth of the sun, Neptune remains a world of deep interest. Its harsh winds, mysterious storms, and captured moon all point to a complex and dynamic history. Neptune may be distant and cold, but it's full of energy, a reminder that the outer solar system is alive in ways we are only beginning to understand. Now, as we prepare for the final chapter of our planetary journey, we'll step even farther beyond Neptune's orbit into a zone of icy bodies and shadows. Awaiting us in that realm is the former 9th planet, Pluto. Beyond the orbit of Neptune, far out in the frigid reaches of the Kuiper Belt, lies a small, icy world that once held the title of 9th planet, Pluto. Although its status has changed, its mystery and beauty remain. Discovered in 1930 by Clyde Tombaugh, Pluto captured the imagination of scientists and dreamers alike, becoming a symbol of the vast unknown waiting at the edge of our solar system. Pluto orbits the Sun at an average distance of about 5.9 billion kilometers, 3.7 billion miles. That's about 40 times farther from the Sun than Earth. Light from the Sun takes over 5 hours to reach Pluto. At that distance, solar energy is weak and the environment is incredibly cold. Pluto is much smaller than any of the 8 planets. It's only about 2/3 the width of Earth's moon. Despite its size, Pluto has a surprisingly complex surface. Thanks to NASA's New Horizons mission, which flew by in 2015, we now know that Pluto is anything but simple. Its surface is covered in ice, but not just water ice. Pluto also has nitrogen, methane, and carbon monoxide ice, each reflecting light differently. One of its most distinctive features is a large, heart-shaped region called Tombaugh Regio, named in honor of its discoverer. Half of the heart, called Sputnik Planitia, is a vast, smooth plain of nitrogen ice that appears to be geologically young and active. Scientists were amazed to find that Pluto, despite its tiny size and distance from the Sun, shows signs of geological activity. This means that its interior may still hold enough heat to drive changes on the surface. Mountains made of water ice, which is rock hard at these low temperatures. There are no impact craters in some regions, which suggests recent or ongoing surface renewal. Pluto's atmosphere is another surprise. Though incredibly thin, it contains nitrogen, methane, and carbon monoxide gases. During parts of its 248-year orbit around the Sun, Pluto's surface warms just enough for some of these ices to sublimate into gas, forming a temporary atmosphere. As Pluto moves farther from the Sun, the atmosphere can freeze and fall back to the ground like snow. Orbiting Pluto is a group of 5 known moons. The largest and most notable is Charon, so big that it's over half the size of Pluto itself. In fact, Pluto and Charon are sometimes considered a binary system because they orbit a point in space between them rather than Pluto's center. Charon's surface is also icy, with deep canyons and ridges suggesting its own history of internal activity. The other moons, Styx, Nix, Kerberos, and Hydra, are much smaller and irregularly shaped. They orbit farther out, and all were discovered in the 21st century with the help of powerful telescopes and the Hubble Space Telescope. Pluto's status as a planet has been the subject of much debate. In 2006, the International Astronomical Union, IAU, redefined what it means to be a planet. According to the new definition, a planet must orbit the Sun, be spherical due to its own gravity, and have cleared its orbit of other objects. Pluto fits the first 2 criteria, but not the third. It shares its region of space with other icy bodies in the Kuiper Belt. As a result, Pluto was reclassified as a dwarf planet. This change sparked controversy and sadness for many. who had grown up with 9 planets. But in truth, the reclassification helped open a new chapter in planetary science. Rather than being the last of the planets, Pluto is now seen as the first of a new class of objects, large, icy bodies in the outer solar system. The Kuiper Belt, where Pluto resides, is a vast ring of icy objects beyond Neptune. It includes dwarf planets like Eris, Makemake, and Haumea, along with thousands of smaller bodies. These ancient remnants are thought to be leftovers from the formation of the solar system, preserved in the cold and darkness for billions of years. The flyby of Pluto by New Horizons marked one of the most remarkable achievements in space exploration. Traveling for more than 9 years, the spacecraft provided the first close-up images of Pluto and its moons, revealing a world far more dynamic and complex than anyone had imagined. It transformed our understanding of the outer solar system. As we gaze beyond Pluto, we enter a realm still largely unexplored. The Oort cloud, a distant shell of icy objects that may surround the solar system, remains purely theoretical. It may be the source of long-period comets that occasionally visit the inner solar system. In this final chapter of our journey, we leave Pluto behind and look out into the infinite dark. Though the planets of our solar system may be familiar now, the space beyond is vast, mysterious, and filled with possibilities. From the blazing heat of the sun to the frozen frontier of Pluto, the solar system tells a story of diversity, motion, and wonder. Our voyage ends here for now, but the universe continues, ever expanding, inviting us to keep exploring, asking questions, and reaching out into the unknown.